Hi, welcome to my channel, JaberTime. Today I'm going to go over linear inequalities and absolute value inequalities. I have them all listed right here, and I'll read some for you, but I'm going to go through some examples. It's better than reading those inequalities, but I have them just like in case if you want to pause the video and look at them. The first one says all real numbers between a and b, but not including a or b. X such that x is greater than a and x is less than b. As an interval notation, we just write open parentheses from a to b. In case if it says all real numbers greater than a, including a, we say x is greater than or equal to a, and we have the closed bracket right here at a all the way to infinity. Of course, infinity we can't use closed brackets because infinity is not a number to be pointed to or included. This one right here, for example, all real numbers less than a or greater than b. So x is less than a or x is less than b. That's much better to look at compared to this right here. As an interval notation, it's from negative infinity to a, not including a, open parentheses, union b to infinity, not including b. Of course, infinity cannot be included. The last one, all real numbers, that means x such that x is a real number, and an interval notation will be from negative infinity to infinity, open parentheses. This is called set indicated, set builder notations. So if you're asked to write set builder notation, that's how you write it. If you want to write interval notations, and that's how you write them. Properties of inequalities. Just like in equations, if you add to these two sides, a less than b, a value of c, as you could see right here, is going to stay the same. It's not going to be equal. It's not going to be reversed to be greater than. So if a less than b, a plus c will be also less than b plus c. The multiplication is a little bit different. So if you multiply by a positive number, c is greater than 0, you keep it the same. ac is less than bc. But if c is negative and you're multiplying both sides by a negative number, you need to reverse the inequality. See, this one is less than, now it's greater than. Just keep that in mind. Also, the properties apply to greater than. I'm listing only the less than or equal, the greater than or equal. For the multiplication one, because it's kind of like a little bit tricky, I'm writing it down by hand. A is less than b and c is positive. Greater than 0 means positive. That implies that ac will be also less than bc, multiplying both sides by the number c, which is positive. If a is less than b and you are multiplying by a number that is negative, notice that I'm highlighting the inequality sign, and now it's greater than, it's not less than. Here's an example. We know that 2 is less than 5. And c is negative 3 being negative. Multiply both sides by negative 3. 2 times negative 3 is negative 6. 5 times negative 3 is negative 15. But if you put the numbers on the number line, negative 6 is to the right side of negative 15. So it should be greater than. Questioning, should it be less than or greater than? It is greater than. It was less than, now it flipped to be greater than. Solve x plus 7 is greater than 9. Subtract 7 from both sides. And now we have x greater than 2. That's an inequality. That's a graph. Greater than 2 means open at 2, not including 2, all the way to the right. As a set notation, from 2 to infinity, not including 2. If you add c to both sides, it's going to stay the inequality the same. So we are adding 15 here for this example. What I have here is on the left, 15 cancels. I have x, 4 and 15 is 19, and we're done. This is the answer. Here's the answer as a graph from 19 all the way down, not including 19. And this says the same thing, from negative infinity to 19, not including 19. In this case, I have x on the right side and I have minus 1 next to it, so I'm going to add 1 to both sides. As you can see, this cancels, and I end up with x on the right side, 7 on the left, and the inequality stays the same. Graphically, from negative infinity to 7, including 7, x is less than or equal to 7. That's how we read it, right? From negative infinity to 7 with brackets including 7. In this case, we're going to divide both sides by 3, or we're going to multiply both sides by 1/3. And 1/3 is a c value, which is positive. So the inequality is not going to flip. As you can see, I'm multiplying both sides by 1/3. This will cancel, we'll take care of this, and we'll leave x alone. And 6 over 3 is 2, or 1/3 of 6 is 2. That's the answer as an inequality. That's the graph. And that's the set notation. We're going to add 1 to both sides. I have minus 2x is greater than or equal to 6. This does not flip when you add. Multiply both sides by -half or divide both sides by -2, either way. This simplifies to x less than or equal to -3. Notice that I'm changing the color right here to show you that it was flipped because I'm multiplying by -half, which is a negative number. Graphically, from negative infinity to -3, including -3, as a set brackets at -3, from negative infinity to -3, including -3. Now let's talk about inequalities with variables on both sides. I have -7x on the left and 10x on the right side. We're going to move them to one side. Let's get rid of the 10x. It doesn't matter which one, but let's subtract 10x from both sides. As you can see right here, this cancels, and I have here minus 17x when you combine them. 13 goes down and -4 goes down. Subtract 13 because we're trying to solve for x and leave x alone. This cancels, and I have here -17. We're going to multiply by the reciprocal, or either way, you could say I'm dividing by -17. And once you do that, you have to flip the inequality sign. This simplifies to 1x, and this simplifies to +1. Graphically, that's the answer. And here's from negative infinity to +1, including +1 as closed brackets. Let's take another example with fractions and variables on both sides. Now I have, as you could see, fractions and variables on both sides. I'm going to move them to one side, so I'm going to get rid of this, subtract 2/3 x from both sides. Once you do that, this cancels, and I have them next to each other, the x's. To combine them, I need a common denominator. Between the denominators 4 and 3, the common denominator will be 12. So I'm going to multiply this by 4 over 4, which is like multiplying by 1. I'm going to multiply this by 3 over 3, as you could see. Once I do that, I do have a common denominator, as you could see, which is 12. Now combine these, minus 9 over 12x minus 8 over 12x will be minus 17 over 12x. We're going to multiply by the reciprocal of this and leave x alone. Once you do that, you have to flip the sign. the inequality sign or symbol. Okay, that will clear the left side, and this should be flipped, and this will simplify to 15 over 34, and that's the solution, all the way from negative infinity to 15 over 34. Now let's talk about compound inequalities, an inequality that has two inequality signs, or a problem that has two inequality signs in the same time. To do that, you could do it two different ways. I'll show you the first way here, and I'll show you the second way to the right side. Here we could say that we have 3 is less than 2x plus 2, which is right there, and also 2x plus 2 is less than 6. So you could break it down to two inequalities. Of course, they have the same pattern, so I'm going to save some time and write at the same time, working left and right. I'm going to subtract 2, subtract 2, I'm going to subtract 2, subtract 2, to leave x's alone. Once you do that, I have 1 less than or equal to 2x, and I have 2x less than 4. I'm going to divide by 2, I'm going to divide by 2, and that's what I have. If you take it back to a compound inequality, this says that your x is less than 2 and also greater than or equal to 1/2. And that's how you say it. X is less than 2 and greater than or equal to 1/2. Graphically, this is what I have, including 1/2 and not including 2 and everything between. Brackets at 1/2, open parentheses at 2. Here's the other way. So if you keep it compound, you're going to subtract 2 from all 3 sides, and then divide by 2 all 3 sides. We're not going to flip, and it gives you the same answer. Okay, let's take another example. Now this time it's compound, and I have x's all over the place on all 3 pieces. You could break it down. That's an option. 3 plus x is greater than 7x minus 2. Also, and 7x minus 2 is greater than 5x minus 10. Subtract x from both sides to leave x alone. Subtract here 5x to leave x on the left side only. Once you do that and simplify, this cancels. I have 3 and I have 6x minus 2. Here I have 2x minus 2. This cancels, and minus 10. Then the rest follows, which is solving for x. I'm going to add 2 to both sides. I'm going to add 2 to both sides. Then I have the following. I'm going to divide here by 2. I'm going to divide here by 6. Nothing is going to be flipped. So I have x greater than -4, and I have x less than 5 over 6. That's another way to write this one, instead of saying it 5 over 6 is greater than x. Alright, let's put them back together, this piece and this piece. That says x is greater than -4, and also x is less than 5 over 6. In one statement. Open parentheses from -4 all the way to 5 over 6, open parentheses. Graphically, from -4 to 5 over 6, not including -4, and not including 5 over 6. Here's something different. Once you have absolute value of x is less than k, that is the same thing as x is less than k and greater than minus k. So it's like in between. We say and. Here we say or. Absolute value of x is greater than some number k. That means x is less than k or x is greater than k. Let's take an example. Describe all values x written within a distance of 4 from the number 5. Absolute value is a distance concept. All the numbers away from 5 will be less than as a distance or equal to 4. When they say within, that means 4 is included. That's an equal sign. The inequality sign has an equal in it. To write this as we have earlier here, less than, we're going to have it as a compound inequality, and that's what we mean. X minus 5 will be less than or equal to 4, greater than or equal to minus 4. We're going to add 5 to both sides, to all sides, or break it down to 2 inequalities. I have negative 4 less than or equal to x minus 5, and I have x minus 5 less than or equal to 4. So you just break it down to 2 pieces. Then you solve each side. We're going to add 5 to leave x alone, and that simplifies to x greater than or equal to 1 and x less than or equal to 9. Put them back together. That's the same thing. Graphically, you are between 1 and 9. Notice that 5 is in the center of this interval, and that explains more. This is 9, this is 1. A distance away from 5 within 4, you could be on either side. That's why we write this inequality as your x minus 5 should be less than or equal to 4 and greater than or equal to negative 4 as a distance. So that's a great concept about absolute value, compound inequalities, and distance. And this one as brackets will be from 1 to 9, including 1 and including 9. This example is different and it's interesting. Before you start solving, saying greater than or less than, compound, or and, well, absolute value cannot be negative. Since the absolute value is always non-negative, whatever you do here, anything you plug in is going to be positive, which is greater than or equal to negative 6. That means the solution is all real numbers from negative infinity to positive infinity. So it's a little bit tricky, but I mean, it's worth knowing that you don't have to waste time here. This is always true. It's always non-negative, which means it's going to be greater than or equal to negative 6. Anything you plug in is going to work. Here's an example for greater than or equal. Greater than or equal means a distance more than 6 or equal to 6. That means you could be on the right side, you could be on the left side, so we use the word or. X minus 6 will be greater than or equal to 6, or x minus 2 will be less than or equal to minus 6. We're going to add 2 to both sides, both ways. X is greater than or equal to 8, or x is less than or equal to negative 4, and that's how we graph it. Greater than or equal to 8, or, see the or makes a lot of sense here instead of the word and, because you can't be here and here at the same time. It's either here or to the left. As a set notations, or interval notations, we use the letter that is capital U here to say union. So the solution is from negative infinity to negative 4, including negative 4, union positive 8 to infinity, including 8. Using a graphical approach to solve absolute value inequalities. Given the equation y equals negative half, absolute value 4x minus 5 plus 3, determine the x values for which the y values are negative. So graphically, they're asking where's the x values such that the graph is below the x-axis. So we have y less than 0, that's being negative. Differently, this is my y, so I'm gonna set it equal to 0. We're gonna subtract 3 from both sides, and we'll get this negative 3 on the right. We're gonna multiply both sides by negative 2 over 1, which is gonna flip the inequality sign, as you can see. And that simplifies to the following. Since it's greater than, we're gonna say or. We're gonna break it down to two inequalities with the word or. And that's what we have. Either 4x minus 5 is greater than 6, or 4x minus 5 is less than negative 6. Add 5 to both sides in both ways. Divide by 4 here, divide by 4. It's not gonna flip. And I have the two options. And that says either x is greater than, which means from 11 over 4 all the way to infinity, as you can see right here, or less than negative 4, from negative infinity to negative 4, negative 1/4, I mean, open parenthesis. Graphically, that's the answer. Either you are to the right of 11 over 4 or to the left of negative 1 over 4. And there is a graph that supports it all in detail. This is an absolute value, a V shape. Because of the negative, it is flipped upside down and it's shifted up 3 units. And this is a shift to the right, as you can see, but we're not talking about shifting. I just want to confirm that the solution is where the y is less than 0 as being negative happens to the right of this point and to the left of this point. And that should do it. Thank you for watching. I'll see you in the next one. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.